Now that we have seen the solution of a linear equation in two variables x and y, which has infinitely many solutions, unlike the linear equation in one variable which has a unique solution, let's enter into identifying the comparison between a linear equation in one variable and that of two variables, as we can do the comparison through conversion. So let's see how we can convert a linear equation in one variable into the two variable form just by using some simple mathematical process. Linear equation in one variable expressed as two variable form. Linear equation in one variable expressed as two variable form. So let's see how we can express in two variable form. So clearly we see that a linear equation in one variable p of x can be expressed in the form ax plus b. So here I write this as p of x as a times of x plus 0 times of y plus b, because when 0 is added to a term it doesn't affect. So I write this in the form ax plus 0y plus b, and hence I get this to be ax with two variables x and y, which is in this form. But this does not satisfy the condition for a and b not equal to 0, because the condition for a quadratic equation is ax plus by plus c equal to 0 with this and this. So this must be a linear equation in two variables x and y. Though this can be converted into the two variable form, cannot be a linear equation in two variables x and y, because it does not satisfy this condition. If a and b are 0, the x and y terms vanish, and hence it cannot be a linear equation in two variables x and y. Say for example, I have p of x is 3. I can write this as 0x plus 0y plus 3, because 0 when added to 3 doesn't affect the value. But since this is with two variables x and y, cannot be a linear equation in two variables, because this is not satisfying the condition a and b not equal to 0. The rules for a linear equation and its respective conditions. Condition 1 and condition 2. Now that we have discussed about a linear equation in one variable and two variables and its respective solutions and the conditions and limitations involved with the linear equations, now let's try to do some example problems to understand the concept more better. This topic is about identifying the coefficients of the linear polynomial or the linear equation. For example, I have the topic about identifying the coefficients of a linear polynomial. So let's see how we can identify the coefficients of the linear equation. For example, we have discussed in the previous sessions that a linear equation can be expressed in general form as ax plus by plus c equal to 0, with two rules. The rule 1 saying that a, b, c must belong to real numbers, and the rule 2 which says that both a and b are non-zero. So with these rules, this linear equation is about identifying the coordinates. So when I want to find the coordinate a, I clearly identify the coordinate A to be the coefficient of x. So for a given problem, if I need to identify the value of A, I pick the coefficient of x and that acts as the value A. B, the next coefficient being B, is clearly understood to be the coefficient of y. Therefore, in order that I identify the value of B in the given problem, I pick the coefficient of y and then that forms the value of B. Finally, it's about finding the constant C. So when I would like to find the value of C, I pick the constant value in the given polynomial or in the given equation, and that acts as the value C. Is how we identify A, B, and C. So the formula for finding A is coefficient of x, and the formula for finding B is coefficient of y, and the formula for finding C is constant. A, B, C are the constants of the given polynomial or the given linear equation, to be identified through the respective formulae definitions. Let's see an example problem to identify the coefficients in the given linear equation. Now here I have a question which says root 2y minus 4 is equal to minus 3/2 x. Now here I have an equation which is given in an unsimplified form. So let's see how we can find the coefficients A, B, and C for this given linear equation. So initially, for expressing this into the general form ax plus by plus c equal to 0, the first thing is about bringing all the coordinates to the left and equating to 0. So let's see how we can bring all the coordinates to the left. As I understand, this can be simplified by taking this minus 3/2 x to the left, because I want only 0 out in the right hand side. So minus 3/2 when brought here reduces to less 3/2 x equal to 0. Now keeping in mind the general linear equation being ax plus by plus c equal to 0, I try to express the given problem into ax plus by plus c form. So let's see how I can express this into this form. So initially I need to have the x term, the y term, and the constant, and then the 0. So let's go with the same rule. An x term 3/2 x, then the y term root 2y, and then the constant equal to 0 is how we express into the general form ax plus by plus c equal to 0 in the general form. Now let's see what is a, b, and c values in the given equation. As we have seen in the previous session that a is coefficient of x, therefore I clearly see that the coefficient of x here is 3/2, or written in the form 1.5 in the decimal representation. So my a is 1.5 because it is the coefficient of x. Similarly, my b is coefficient of y, which is clearly root 2, is what we get for the value of b. And my c is clearly the constant, including the sign. Do not forget to put the sign for a, b, or c for the respective coefficients. Coefficients add up along with their sign, positive or negative, as given. And c is the constant which is minus 4. Therefore, A is this, B is this, and C is this. And finally, I get my A, which is 1.5, B, which is root 2, and C, which is minus 4, is how I understand the identifying of the coefficients in the linear polynomial in two variables x and y. A is coefficient of x, 1.5, B is coefficient of y, root 2, and C is constant, minus 4. But it's very important to note that this formula is not applied directly in the unsimplified form. The rule is about converting the given linear equation into the standard form ax plus by plus c equal to 0, and then pick the values of a, b, and c using the formulae as learnt. A, B, C can be found using the process.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.